I'm Chimila Ariasaf, and we are talking about today. We are talking about MLOps, meaning machine learning operations. Machine learning ops or operations. They are just refers to the practices and the tools and methodologies that are just used for streamlining and deploying of our model and monitoring it into production in the production environment. Like if a model has been deployed, the techniques, the tools we use, that's all about MLOps. Its relevancy in our project. Model deployment. First of all, it will allow us to deploy our models and monitor. When we talk of model deployment, it's like it will allow us to operationalize and analyze our data, our model, and make real-time predictions based on a customer review data. Then we have another point, the continuous integration or continuous deployment. By this, when we implement this pipeline as part of our practice, we can be able to automate the testing, deployment, and monitor our machines or the model and ensuring that they remain accurate and up to date as new data becomes available. Then we have scalability and efficiency. This will enable us to scale our machines, the models efficiently and allowing us to handle large volumes of customer reviews after it has been deployed. Then we have versioning and reproducibility. Versioning and reproducibility will allow us to ensure that we can track changes to our models and the dataset and our code over time. Like versioning can be an example I can give about versioning is the GitHub. GitHub can allow us to host our code there or to provide a repository for our code. So when we need to make changes, we can just pull that code, we make changes, then we put it back like that. Then the next point is model performance, monitoring and management. MLOps will allow us, since it provides the tools for monitoring and management, it will allow us to monitor the performance of our model and detecting if there is any drift or degradation in our model. Then we have collaboration. When I talk about collaboration, it's collaboration between the developers. It helps us to collaborate. Like we can host our code on GitHub. We can put it there on GitHub. Drive. Anyone can go there, make changes to the code. So if a new developer comes in and wants to change something, just pulls the code, then adds on it, then pushes it back like that. We talk about how these MLOps trends and techniques will influence our project. First point is automated deployment. Like it will enable us to deploy our model quickly and effectively and efficiently into production environments. Then we have continuous integration and continuous deployment. Like we will implement these pipelines for our model to ensure that the updates of our model can be seamlessly integrated and deployed. We have scalability and efficiency. Like the MLOps techniques will enable us to scale our model and handle large volumes of customer data. We have model monitoring and management. Like since these techniques emphasize on model monitoring, it will allow us to track the performance of our model in production. Then we have collaboration. Since these MLOps techniques promote collaboration, it will allow us to collaborate to im- as members to improve on our project. Here we talk of the applications of DevOps and DataOps in our project. We begin with the DevOps practices. And remember, these practices facilitate automation, version control, and continuous integration and continuous verifying. So if you want to apply this, it can be applied through all those practices like automation, the continuous integration and continuous deployment, and version control. And it can ensure that the model is reliably deployed into production and efficiently to enable rapid iterations. Then we talk of data ops. These techniques allow us to streamline data ingestion and pre-processing and transformation. Like through all those techniques, we can ensure that the Amazon data is cleaned and standardized and ready for analysis. Then when we apply that, we can maintain data quality and reliability throughout the machine learning cycle. We have the difference between heavy and light MLOps in our project. MLOps, we can give this based on other techniques. We're gonna provide it based on other techniques. And MLOps techniques may include automated deployment, pipelines, continuous monitoring of model performance, versioning of model and dataset, and collaborative workflows. So when we implement those that I've mentioned, it means that we are using the heavy MLOps techniques. On the other hand, the light MLOps this focus on the essential practices of deploying and managing machine models, like prioritizing and simplicity. Prioritizing and simplicity. It prioritizes simplicity, efficiency, agility, the cost effectiveness, and makes it suitable for rapid prototyping and low risk projects. Then moving to the next, here we talk about integration of MLOps hierarchy of needs into our project. First of all, we begin with foundation, and at foundation we will ensure that we have the foundation elements in place, such as the version controller, automated testing, and basic deployment pipelines. Then we talk of visibility, like we will establish monitoring and logging mechanism to gain visibility to the performance and behavior of our mechanism. Then we talk of automation, and we will implement automation techniques to streamline repetitive tasks such as data pre-processing, model training, and deployment. Then we have governance. We will establish governance frameworks to ensure that compliance with regulations and maintaining data privacy and security throughout the machine learning life cycle. Then we talk of continuous improvements. We will ensure or we will foster the culture of continuous improvement by regularly evaluating and refining our MLOps practices based on feedback from customers. Here we talk about integration of MLOps maturity model in our project. We'll begin with the initial stage. At the initial stage, we'll focus on establishing basic MLOps practices such as version control, code, and data. Then model deployment ad hoc and manual monitoring. Then on the next stage, the managed stage, we will make sure that we implement more structured processes such as automated CI and CD pipelines, model versioning, and monitoring capabilities. Then we talk of the defined stage. At this stage, we will formalize the MLOps processes and governance structures by implementing robust monitoring and alerting systems. Then we talk of the optimized stage, and when we reach at this stage, we continuously optimize and refine our MLOps practices to leverage the techniques such as automated motor retraining, A to B testing, and advanced model monitoring. Here we talk of the strategies to handle data poisoning, data drift, and operationalizing microservices. We begin with data poisoning. And here I'll explain like two points on each. We have the model interpretability, and here we enhance model interpretability and transparency to detect and mitigate the impact of poisoned data on model prediction. Then we have data quality assurance. We implement rigorous data quality assurance processes to detect and mitigate instances of data poisoning. Then we have data governance, like only trusted sources contribute to the training data. Then we go to data drift. We have continuous monitoring. We implement continuous monitoring of data distribution and model performance to detect and adapt drift over time. Then we have feature engineering, like we design features that are robust to changes in data distribution and can generalize well across different environments. Then we talk of operationalizing microservices. We have automated deployment, like we implement automated deployment pipelines for microservices to streamline and release processes and ensure consistency across different environments. Then we have monitoring and logging. We use centralized logging platforms and monitoring tools to gain visibility or insight on the health and performance of the microservice. Then we talk of API design, like we use standardized protocols such as RESTful APIs and or gRPC for communication between microservices. Here we talk of the role of CID, CI/CD feature stores and the importance of specific files in our Python project. We begin with the roles of CI/CD and feature stores, and continuous integration will allow us to integrate whenever change is made in a code. We can be able to integrate it to the deployed version. Then we have the continuous delivery. Like in our project, we will automate deployment of our analysis model to production environments. Then we have the feature store. The feature store facilitates the management and reuse of features extracted from the data, the customer review data. Then we talk of the specific files. The specific files mainly we have three: the README, the setup API, and the requirements.txt. The requirements.txt is all a is a file that lists dependencies that are required for the Python project. Then the setup.py file defines the metadata about the Python project and the instructions for installing and distributing of packages. Then we have the README. The README contains the documentation, usage instructions, and important information about our project, like what your project is all about is the documentation of your project, what it's all about, what it's doing, it's all about, it's found in a README.